So hello again. This is the last panel I am doing at CoKoCon. And for those who don't know, I run Galactic Journey at galacticjourney.org, where I live exactly 55 years ago from the respective you folks. So for me, it is currently September 5th, 1966. We just watched the second Star Trek pilot because we are also at Cleveland at TriCon, and Gene Roddenberry showed it to us. And we're at a very exciting time vis-a-vis the space race. Gemini 10 has gone up. We're about to have Gemini 11 next week. The Mercury program is gone. The Apollo program looks like it's going to launch at the end of this year. We might have a person on the moon by the end of 1967. And this space race has mostly focused on people like the astronauts, or maybe some of the flight controllers, or some of the people behind the scenes like Jim Webb or Werner von Braun, good Americans like Werner von Braun. But what it often has not focused on is the fact that a number of women have been involved both in NASA and without, who have made our current space successes possible. And today, I'm going to tell you about some of them, some of whom you may have heard of, and some you may not have. Now, I'm going to be doing so from my perspective of 1966. However, thankfully, some folks from the future have come back and told me a bit about some of the successes that these women have had since 1966. So I'll make sure you get the whole picture. So hopefully everyone can see my projector. It's a 3M portable projector showing the women pioneers of space science. And if everyone is seated comfortably, then we'll begin. So when I say the word computer, that probably brings to mind some sort of room-filling electronic device that sends you bills or books your airline ticket. Or for you folks in the future, it might be something you carry around in your pocket. Miracles. But back in the day, speaking in the 19th century, a computer was actually a person. That's someone who did mathematical calculations, because back then there was a lot of grind work in figuring out mathematical things. And so you would hire a room full of people to do your math for you. And traditionally, they were women. Now, the computers we're going to be talking about were managed by a man named Henry Pickering. Henry Pickering was an astronomer in the 19th century, and he discovered spectrographic binaries. And what those are is, normally you look in the night sky and you can't see two stars that are in close orbit around each other because they're too far away. They resolve as one star. But using a telescope and a spectrograph, you can actually determine that there is more than one star there. So what Pickering did is he did tons of observations of binary stars. And you can see one in the background right there in this picture. And then he handed it off to his computers. And the computers that he had were run by one Henrietta Swan Leavitt. And Henrietta Swan Leavitt did something very exciting. She went through all this spectroscopic binary data, and she found out that there was a certain kind of binary star called a Cepheid variable. And she determined that there was a direct relationship between how fast these stars rotated, their period, and how bright they were, their luminosity. Now, why is that exciting? Because if you know how bright a star is, then you know how far away it is, because you know how bright it's supposed to be, and then you can tell how bright it is from where you are. When you know a star's period, you know how bright the thing is supposed to be, and then you just account for how bright it actually is, and you say, it's that far away. What Henrietta Swan Leavitt did was she discovered the first cosmic yardstick, making it possible, expanding our range of where we knew stars were from tens of light years to hundreds and thousands of light years. It cannot be overstated, her contribution to astronomy. And to this day, this galactic yardstick is known as Leavitt's law. Now, why am I starting back in the 19th century rather than the 20th? The answer is computers continued to be a thing well into the 1950s. That's Henrietta Swan Leavitt, by the way. By the 1950s, computers were doing things like computing the path of rockets, going to the edge of space. And they were hired by places like NACA, the National Advisory Committee for Aeronautics, which was the predecessor to NASA, and also places on the West Coast like Jet Propulsion Laboratory. So some of you may have seen the movie Hidden Figures, and Hidden Figures has a great subject matter, 3 computers on the East Coast. And we're going to start with one of them. This is Dorothy Vaughan. She had a BA in mathematics, and she started out as a computer at the West Ford Computing Unit at Langley Research Center. This is before there was a NASA. This is back in World War II in 1943. Now, within short order, she was actually heading the unit of computers. Now, what's interesting about the West Area Computing Unit at Langley is, like many other institutions in the South, it was segregated, which meant you had a facility with white women and you had a facility with black women. She was running the black women staffed unit. Now, she eventually became the first black manager at NACA, and in 1958, NACA became NASA, and all segregated facilities were abolished. And so that's one interesting stretch of things that they did in Hidden Figures. By the time of the events of the movie, NACA was already NASA, and the facilities were already integrated. And they were integrated by the government, not by Kevin Costner. But Kevin Costner makes more money, and therefore that's how the story went. Now, as NASA came into being, by the late 50s, the writing was on the wall because they had invented computers. We were already in the second generation, computers like the UNIVAC and the IBM 7090. These were computers that clearly could be able to do computations faster than humans could. Dorothy Vaughan took note of this, and she started to learn programming herself. Particularly, she learned one of the first higher level programming languages called Fortran, which is Formula Translator. It's a scientific programming language. It's still very popular in 1966, and in fact still has currency in your year of 2021. And what's really cool is she taught her people how to program in Fortran. So that way, as many as possible could make the transition. So when the West Fort area, when Langley became computerized with actual digital computers, she had the know-how and her staff had the know-how to continue being computers. What's really interesting is, of course, back then computing was considered women's work. Men wouldn't dirty their hands with such things. And so they had jobs. And it's really interesting. This is not the case in other places like schools and businesses. There it was still a male-dominated field. But at NASA, computing was a women-dominated field, much like secretarial work at the time. So Dorothy Vaughan went on to join NASA's new Analysis and Computation Division. And as of 1966, she's still there working on the Scout rocket, which is a cheap and reliable solid fuel booster. Looking into the future, she will retire, a much lauded and missed professional. In 1971, she will sadly pass away in 2008. I'm sure this person is no stranger to you. This is Katherine Johnson, who had a BS in mathematics and French. She was actually one of Dorothy Vaughan's proteges. She worked at the West Area Computers Unit from 1953. She went on to be in the Flight Research Division after NASA was formed. She got deeply involved in the Mercury program. Significant about her, in 1960, she became the first woman at the Flight Research Division to receive credit as a co-author of a research report. It had the catchy title of Determination of Azimuth Angle at Burnout for Placing a Satellite Over a Selected Earth Position, which is a very important subject because it tells you where a spaceship is going to be at any given time. And that's the kind of thing that's important for things like Alan Shepard's first suborbital mission. And you may remember in the film when John Glenn calls her up to find out if the calculations were okay, not wanting to go to orbit until she gave the sign off on them. This actually happened, not in quite a dramatic way as in the film, but he definitely asked, and she definitely said they were okay, and he definitely took her word for it. Glimpsing into the future, right now she's currently working on calculations that sync up the lunar module to the command and service module of the Apollo. She's going to go on to work on the space shuttle and the Earth Resources satellite. She's ultimately going to author or co-author 26 research reports. And she passed away quite recently. and was a great inspiration for scientists and computers and engineers everywhere. The third person who was in Hidden Figures is Mary Jackson. And Mary Jackson is interesting. She's not exactly a space pioneer because her field was wind tunnels and testing the aerodynamic properties of aircraft designs, which is something else that NACA and ultimately NASA did. In fact, you may not know this, but 2/3 of what NASA does is aeronautical rather than astronautical. For those of you who looking into the future, when you fly an aircraft, you see those little winglets that curve up. That's a NASA invention. The grooves in runways that now are in our highways, also a NASA invention for airplanes. So Mary Jackson has a really cool story. So she was originally a math teacher with a dual degree in math and physical sciences. And she also worked at Langley from 1951, working for Dorothy Vaughan. And you may remember in the movie, they talked about how Katherine Johnson was not allowed to go to the bathroom in the white women's bathroom. And so she had to run across the campus, and she came back and she cried, and eventually Kevin Costner fixed the bathroom situation. Well, what actually happened is they told Mary Jackson, oh, you have to use the black women, the colored facilities way over there. And she said, no, I'm not doing that. And then waltzed into the white women's bathroom and did her business. I like that story a lot better. And it shows what kind of person Mary Jackson is. And let's talk about what kind of person she is. So 2 years after starting to work at Langley, she received an offer to work for the engineer Kazimierz Zarnecki in the 60,000 horsepower supersonic pressure tunnel. And she took the job, she proved herself, and Zarnecki wanted her to take graduate level work so she could get a degree in engineering. The problem is all the graduate level math and physics classes that were offered by the University of Virginia were segregated. And she could only go to the all-white Hampton High School if she wanted to take the classes. So she had to get special permission from the city of Hampton for that. And as you saw in the movie, she succeeded. And that is absolutely true. In 1958, she became NASA's first Black female engineer. And that same year, she co-authored her first report, Effects of Nose Angle and Mach Number on Transition on Cones at Supersonic Speeds, which has applicability to airplanes and spaceships alike. Now, what I love about Mary Jackson is she would go on to work for 2 decades, basically getting to the top of her field, co-authoring a dozen research reports, mostly working on the boundary air layer around airplanes. But she determined that there was a glass ceiling. There was only so far she could go. Moreover, she saw that her colleagues were hitting the glass ceiling as well. And so what she did was she left her engineering position. She took a demotion to fill the open position of Langley's Federal Women's Program Manager. And there what she did was she hired and promoted the next generation of NASA's female mathematicians, engineers, and scientists to ensure that there was a huge core of qualified women who could then break that ceiling. And I think that's just wonderful that she took her success and then helped everyone else out. Mary Jackson is just one of my favorites. She retired from Langley in 1985, and she passed away in 2005. So from the East Coast to the West Coast, Jet Propulsion Laboratory was a division of Caltech. They designed rockets for the Army. They had computers that determined trajectories of missiles, and they became very important in the early space program. So this is Sue Finley. She had the most improbable path to becoming a computer you might think of. She spent 3 years in Claremont College. Now, you folks are in Arizona or wherever, so this may not be significant to you. Claremont is only about 20 miles south of where I live here in Vista. So she was studying art with the goal of becoming an architect. But the problem is she found out her credits wouldn't transfer to an architect school. So she applied for work in an engineering company to be a typist. That company happened to be hiring computers at the time, computers being the human computers. And they said, do you like math? And she said, I like math a heck of a lot more than I like typing. And so they gave her the job of computer where she would do calculations for a number of engineers. She didn't do it all in her head. As you saw in the movie, they actually had these giant Frieden calculating machines that they did their work on. And she did the work, she and another woman did the work for 40 different engineers. Now, after a few months, she got married and she moved, and the commute was too far. And of course, you know, the man's job comes first. So she stopped and became his wife for a while. So he had graduated from Caltech, which of course manages JPL. And eventually he said, hey, you know what? You should go for a job at Caltech. And so she did. And it turned out she got hired to be a computer just a couple of days before Explorer 1, the first American rocket. Now, she came in too early to do any work on that. Now, then her husband went to get his master's degree. And again, she had to take off work because that's what women do. But in this hiatus, she decided to take a programming language as well. She learned Fortran just like Dorothy Vaughan. And a few years later, she went back to work for JPL as a computer, but on a digital machine. And here's what's really neat. So my favorite thing that Sue Finley ever worked on at this time was computers were fast, but they were only fast at doing pre-programmed things. And when there was a calculation that had to be done in a hurry, people were still better. When they launched Ranger 3 in 1961, I think, maybe 62. I think it was 61. It missed the moon. It was supposed to hit the moon. It missed the moon. And they got her to do calculations on the fly to figure out that it was going to miss the moon by about 25,000 miles. So nice work by a human computer, like Paul Bunyan beating the machine. Who's the guy? Who's the guy who beats? Anyway, John Henry. Sorry, I should know my Americana better. So Finley, in her position, then went on to continue doing calculations for space navigation. In the 80s, she moved over to the Deep Space Network, which is really exciting. The Deep Space Network is a network of big antennas that can track spacecraft far away from the Earth. Without them, you cannot do deep space missions. And she did the calculations for them. She ultimately retired, but she is still alive. So that's Sue Finley. Now, we've been talking about computers. Now I want to talk about women who were scientists in their own right. The woman on the left is Marcia Neugebauer, who had a master's degree in physics. She majored she went to Cornell. She was in New York at a time when girls didn't major in physics. She was, in fact, the only woman in her class, which she actually liked. She said that when there was more than one woman, all the men would ignore them because they would assume the women would talk to each other. But with only one woman, she could be one of the guys. Interestingly enough, here in 2021, my daughter was valedictorian. She is now in a Calculus 3 class. And there were two women in the class. She is now the only woman in her class. How times change. So anyway, Marcia Neugebauer, her specialty is the solar wind, the constant rain of charged particles that comes from the sun and interacts with the Earth's magnetic field, causing aurora borealis and other interesting issues, not to mention the ionosphere, which makes AM radio possible. Because that was her specialty, she was hired by NASA to do the solar wind measuring equipment on Rangers 1 and 2, which, unlike Rangers 3 and beyond, were not designed to go to the moon. They were simply sky science satellites. Now, Rangers 1 and 2 did not work. However, the first Mariner to Venus was based on the JPL Rangers, and they used Marcia Neugebauer's solar wind equipment because we had this probe that was going to Venus, which was closer to the sun than the Earth, and it could do in situ measurements of the solar wind. So Marcia Neugebauer was the creator of the instrument that allowed us for the first time to do long-term measurement of the solar wind closer to the sun than the Earth. Pretty amazing stuff. She went on to continue working on solar wind equipment on satellites, on the ALSEP, which was equipment that was left on the moon by the Apollo astronauts. She also worked on instruments for the Giotto, which was a probe that went past Halley's Comet. And she was manager of Mariner Mark II, which ultimately became the Voyager project. And she was also manager the principal scientist on the Comet Rendezvous satellite, which unfortunately got canceled, but still shows you how far someone could go when they had the stuff. Now, interestingly enough, the person to her right is Phyllis Buwalda. And when I was originally putting together this presentation, I didn't know who this person was. But she was in the picture, and I felt I couldn't have her in the picture and not talk about her. She was a computer at JPL at the time, and she was involved with Project Ranger. She later directed future mission studies at JPL. But what's really neat about Phyllis Buwalda, her biggest contribution was in the mid-60s, after Project Ranger, which was a probe that went to crash into the moon, had a TV camera on the end of it, we launched the soft lander probes called Surveyor. And surveyors would land on the moon, stay there for months, and take pictures. And some of them were equipped with this little rover that would detach, land on the moon, and go around a little bit, had wheels. Now, at the time, the project was stalled because no one knew what the surface of the moon would be like. Was it quicksand dust? Was it hard, baked, like the desert or whatever? We didn't know. And so nobody was doing anything. And Phyllis Buwalda said, look, let's just take the most rough terrain we can think of. And by the way, we have an example right outside in the Western desert. Let's plan for the worst, and then it'll work in any situation. So she cut right through that red tape, and in fact, it worked. So way to go, Phyllis Buwalda. Unfortunately, I've lost track of her from that point. I don't know what she ended up doing after that, but we can certainly be thankful for that because the Surveyor mission was one of the more successful NASA missions. I think 2 out of 4 succeeded, and at one point, an Apollo astronaut actually got to see one on the moon. All right, now we're going to go to my favorite, and partly she's my favorite because nobody had done much research about her until I discovered her. So my specialty is the early space program, particularly 1957 to 1960. In particular, the work done by Space Technology Laboratories, which was an Air Force shop, essentially the military counterpart to JPL, and they had an interesting cross-San Gabriel Valley rivalry. Lori Frankie van der Waal had a very interesting history. She was 6 feet tall, tough as nails, and as you might guess, had to fight for her place in a man's world. She was a 15-year-old high school graduate. She was a model at one point. She was also an airplane mechanic, a deputy sheriff, a showgirl, and she graduated with a master's in aeronautics. So she went to work for STL as a bioastronautics person. Now you may wonder, well, what's a bioastronautics person going to be doing at a place where they're launching missiles for the Air Force? Well, actually, the two became related because of her. So in 1957, Sputnik launched, and everybody went nuts because clearly the Soviets were so far ahead of us. And a fellow named Gideon, who I actually met, he came up with the idea of let's take the Thor intermediate range ballistic missile that we're currently basing in England and stick a Vanguard second stage on it. Vanguard hadn't even worked yet. And we will launch it suborbitally with a nose cone on it. And with that, we can actually test ICBM capability, even though we don't have an ICBM yet. And eventually, we can also use this rocket to launch probes to the moon, which they tried. They didn't work, but they got halfway, which was pretty neat. So they did all these missile tests of these nose cones on what was called the Thor Able missile. And she said, you know what? These nose cones are empty. Why don't we use them for biological testing? Let's put mice in them and put telemetry on them, and we can figure out what acceleration and weightlessness does to animals. And this was new stuff. It had been done on the Aerobee sounding rocket a few years before, but never with this kind of velocity or range. So she would strap these mice into this harness. And I remember talking to Bud Sonnet, who was a project manager who was across the hall from her. And she said, come in here, help me hold down the mice. And all he remembers is that it bit him and peed on him. So he was not particularly happy to be part of this experiment. But anyway, they launched 3 of these Thor Ables. They called them Mouse in Able. So they were all called Mia. None of them survived. They were all lost floating in the Indian Ocean, sadly. But they did get back a lot of data. They figured out that the mouse heart was like an accelerometer. They could tell how fast the rocket was going just by how fast the mouse's heartbeat was going. And so this is some of the very first biomedical experiments in space, Miss Frankie van der Waal. Now, she ultimately left STL. She got married and then became a fairly important person in the in local government. But man, did she live in impact, and she impressed everybody she worked with. Now, this is someone I found out about fairly recently. She was actually the subject of a NASA documentary. I think it was called Woman in Charge. And she is. This is Marjorie Townsend. She also enrolled in college at 15 and became the first woman to be graduated from the George Washington University School of Engineering. And there was this, at the time, everyone said, oh, she was just in school to get married. There was a gentleman actually put a wager on it, and he had to pay up at the end because she did it to get a degree. Although she did ultimately get married to another scientist. She was one of the first female engineers to join NASA. She was at Goddard Space Flight Center in 1959. And what she was responsible for initially was the ground processing equipment for the medium resolution infrared equipment on the Tyros weather satellites. In 1960, NASA launched the first civilian weather satellites. And a satellite is as much the ground equipment as it is the equipment on the satellite, because you have to take the data, process it, translate it into something people can read, make it pictures. That was her job. And you see her here, all those guys there, they work for her. She is in charge of them working on this Tyros equipment. She has gone on in the mid-60s to work on Nimbus, which is the second generation weather satellite, and also the Orbiting Geophysical Observatory, which is in fact an SDL satellite. And these do long-term measurements of electromagnetism and magnetic fields around the Earth. She is going to go on to manage NASA's Small Astronomy Satellite Program. This is going to culminate in the launch of Uhuru, which is an X-ray satellite that will be launched in the late 60s. So that's Marjorie Townsend. I'm saving the most important for last. All of these women are fantastic, but this one probably had the biggest impact. This is Dr. Nancy Grace Roman with a PhD in astronomy. So when she started, she was born in Tennessee, and when she began her professional career, she wanted to take her second year in math instead of her fifth year in Latin. And she was told by a professor, why would a lady want to take mathematics instead of Latin? But she did it anyway. She became a grad student at Chicago's Yerkes University in the 40s. And at the time, Yerkes was pretty much the center of astronomy. A very famous person there was Subramanian Chandrasekhar, very, very famous astronomer. While she was there, only 20% of the students were women. And there was no explicit discrimination against them, but they only made 2/3 as much money as the men. So she went to Chandrasekhar and she figured this fellow is also not, he's of a minority extraction. Surely he understands discriminations. He said, hey, what's the deal? And he said, of course we only pay 2/3. You'll work for 2/3. So she left. She went to the Naval Research Lab in 1955. And when she went there, she got no assignments. She was completely frozen out. So eventually one of the NRL staff went up to her and she said, what's going on? And he said, well, we had a woman once and she didn't work out. And so that attached a reputation to the entire gender of women. Well, of course, she was very good at her job and won everybody over eventually. And in fact, in 1959, she was tapped by the new organization, NASA, to lead their space astronomy department. She became the most senior woman at the agency, chief of astronomy, NASA Office of Space Science. And what you see in that picture right there is the Orbiting Solar Observatory. This was the first big satellite that NASA launched. Before then, NASA was launching Explorer-class satellites that were not very big. They were important, but they'd have like one experiment on them, maybe two. Meanwhile, the Russians were launching big things like Sputnik 3. So this is the first observatory-class spaceship, and its job was to sit and look at the sun with 12 instruments for a long time. This was her project, would not exist without her. She's also gone on to the Orbiting Astronomical Observatory, which is a visual telescope in space. She's working on their ultraviolet astronomy efforts. there's a whole series of OAOs and OSOs that she's going to be working on throughout the decade. And she will be known in a couple of decades as the mother of Hubble, because she's going to organize the committee of astronomers that designed the Hubble, which is still in use here in 2021. She passed away in December 2018 at the age of 93. Now, why am I talking about this? It's not just because these are cool stories or interesting people. I mean, they are. And it's important you know about them. But it's not just to celebrate them. Although Lord knows these are unsung people. Only some of these people you've probably ever heard of, and yet they all deserve as much celebration as anybody else. But beyond that, what's important to understand is without them, these accomplishments that I described may not have happened. We can't take it for granted that someone else would have filled this position. These people did unique things at unique times that made these projects possible. And what this underscores is when you open up a field to more people, to a more diverse crop of people, you increase the talent. Everybody benefits when there are fewer barriers to success. It brings in people you would never have had access to. You're able to make more projects possible. You're able to make more projects work because you have the right people for it. So this is why it's important that we know about these women, why it's important these women did what they did, but because of that, in 2021, women are now fundamental partners, and not just women, but other minorities as well, other marginalized people. But they were the pioneers. They did it first. And I hope you appreciate having learned all about them. And I see we have some questions. Oh, we have no questions. Someone is mentioning that Nancy Grace Roman has a telescope named after her. Yes. And also some discussion that these are people who were intentionally erased. It is certainly a fact that people tend to perpetuate their own kind and they have their own narrative. That's why I think it's so important for people like Mary Jackson, who made sure that she would not be a one-off success. She would continue to, she would have a legacy of bringing more people into it. Can I recommend some books on women's accomplishments? I wish I could. All the research I have done has been actual papers or people. I mean, with Frankie Vanderwall, it was actually, I went to the Northrop Grumman Museum and got information and interviewed her cohorts. And Bud Cohen wrote, Bud Sonnet, not Cohen. No, it's Cohen. I'm Cohen. Sorry, Chuck Sonnet, Bud Cohen, two different people, same project. Bud Cohen wrote an article about her as well. But I'm afraid I know there is a book for Hidden Figures. I understand it's a lot more accurate than the movie, so that's probably worth picking up. But I suspect other people around have better recommendations than I do. I'm sorry. We do have a series called The Pioneering Women of Space Science at galacticjourney.org. It mostly covers what we've just talked about. At some point, I'm going to do a second installment because there's a whole other crop of women who've popped up who've done important things, including, you've probably seen the picture of the Apollo programmer who's got the stack of Apollo code up to her ears. That's probably someone we'll need to cover. So that's what I got for you. I hope you enjoyed it.
Somebody mentioned that it's The Glass Universe by Dave Sobel, who were about the women, the women who were astronomers at Harvard.
Yeah, and I rushed through it. I'm sorry. Normally I finish later than that. But go ahead and I can answer more. I can do my best to answer questions.
Well, you've got a few comments in the chat.
Those are great.
Yeah.
We're definitely still in the mid 60s in a man's world time. And especially with computing at big universities and at IBM, you've got these sort of priests of the computer in their white coats, and they try to keep the computer isolated. Something that's going to change the situation, though, is time sharing was just invented a couple of years ago, and that's going to allow a lot more people to have access to computers. but it's going to be a long time before women reach any kind of parity. What's really a sad note is women were actually getting into computers in the late 70s, and the demographic ratio was getting better. And then in the early 80s, right when computers were becoming a home installation, all the marketing was aimed at men and boys. And women were actively discouraged from pursuing computer careers. And so you see a distinct drop in women going into computing after the early 80s. It's really kind of amazing that they had such a role in the 60s and then a discontinuity after that. I will say when I was taking astronomy in the 90s, half our class was women. Oh, and speaking of which, Carolyn Shoemaker just passed away the other day. She was the wife of Gene Shoemaker. They were both geological astronomers together. Someone is noting that women in engineering were forced out of the profession by bigotry. And that's something that still goes on today. You've seen the scandals at Blizzard right now, where it turned out that that company was run like a frat house and women were treated terribly. And the company may go belly up as a result because they're finally seeing there's finally light being shined on that. Someone is pointing out the number of women who were engineering students in the USA peaked in the mid 80s, right? And it's been going down ever since. But all we can do is bring these classic women to the fore. That's why I'm glad we're having movies like Hidden Figures. I honestly would have preferred if Hidden Figures had been an hour-and-a-half documentary on these amazing women's lives rather than the sort of Hollywoodized white savior Kevin Costner myth. But I'm glad that we're starting to get some role models that can inspire people. My daughter, as I said, is actually right now she's a math major, so we'll see what happens. But she also wants to take dance, so curse of the gifted child. Janet Worley says, in 1998, my alma mater, the University of Washington, was stunned to discover that the number of women applying to the Department of Computer Science was 0. I'm not surprised. Even when discrimination is unconscious, you get a situation where if you have an all-male club, it's discouraging to anybody else. Same if you have all white males, then marginalized people of other origins don't feel like they are acceptable. Someone is talking about the Mercury 13. So the Mercury 13 are interesting. The first people chosen to be astronauts in 1959 all had to have a certain degree of test pilot experience, and they had to be military. And while they did not explicitly exclude women, those requirements made it so women could not apply. And when they were starting to cast about for the second group of astronauts, what we call the next 9, who ultimately came in 1963, Jerry Cobb, who was a test pilot, pushed for 13 candidates who ultimately took all the same physical tests that the Mercury astronauts did, and who were all pilots in their own right, and said, hey, let us in. Ultimately, they were laughed out of Congress. There was never any serious consideration of women to be in the role. And of course, this was all rather embarrassing when the Soviets orbited Valentina Tereshkova in 1963. We, of course, learned later that Valentina Tereshkova was not an autonomous pilot. She was chosen because she could parachute, but the Soviets were also using women as a propaganda tool and never really intended to have women be equal partners either. Despite the Soviet Union supposed to be a place where there was gender equality, there really wasn't. But women were not considered for the space program until the 70s. And they probably could have gotten in Group 4, which is the scientists, in 1967. But I don't know that they were ever considered or if there were strong barriers to it. Someone talks about von Braun being part of that. I don't think von Braun was of outsized importance, and I have my own feelings about him, but I don't know. He was not directly involved in the Mercury program. so this was institutional. And in fact, when we were first casting about to put people in space, originally we considered lots of different people. We considered people who were based in Antarctica because they were used to isolation. There was discussion of using amputees because they used less oxygen because they had less mass. And ultimately, I believe it was Eisenhower said, you know what, let's just go with test pilots. It's not perfect, but we know that test pilots can do the job. And if we just limit the Corps to test pilots, then we know we'll get people who will work. So part of it was passive discrimination. Part of it was efficiency. Paula Lieberman talks about one of the women sexually harassed on the Antarctic field trips by David Marchant, a former BU professor, made former by her going public with an accusation once she had tenure. And this is on a PBS show. Fascinating. Yeah, it has always been tough. I always have such respect for the women and other marginalized people who persevered in this time when it was very difficult to persevere. And the second wave of feminism is just peaking here in the mid-60s. And that's going to change things by the 70s, but it's still going to be an uphill fight. And in some ways, by the 21st century, still is. I have not seen For All Mankind. From what I've heard from it, it's not a particularly plausible alternate history. And from my experience, not a lot of people can write plausible alternate history. I've got an alternate history where the Soviets do make it to the moon a few months after the Americans and keeps the space race going for a little while longer. I've got a story called Andy and Tina, which is about Valentina Tereshkova and her husband, Andriy Nikolaev. That I think is pretty cool. You can find it as the lead details from Alternate Earths 2. I'm also going to release it in my collection Claire Voyages next year. But I won't tell you the secret because there's a twist. But it stars Valentina Tereshkova. But yeah, von Braun is I think my feelings on von Braun can be best summarized in Tom Lear's song, which you can look up if you don't know. Or as they said about the biopic of Wernher von Braun, I aim for the stars, but sometimes I hit London. Right. Someone talks about how the NASA engineers and astronauts were not necessarily felt that they were discriminating. They were just, well, we're only going to hire the best and the most talented, and we're just going to make sure that it's always men who happen to fit those requirements. Again, this is why someone like Mary Jackson is so important. And Dorothy Vaughan, for that instance, right? She trained dozens of computers to be able to make that transition to computing at NASA. Had she not done that, there would have been a lot of people out of a job and we would have lost that continuity of talent. Paula Lieberman says she was doing market research and bra companies are located in a part of the US where women who are engineers from here don't stay here and women from other parts of the country won't come here. So bra design is done by men. Also mentions the requirements for being a pilot were having military flying experience and the military banned women from flight status. Exactly. And by the way, that was what was so exciting. We watched the first pilot of Star Trek yesterday, The Cage, and they had a woman as the first officer on a starship with the ship's complement of essentially a destroyer. And that's something that would not happen in the US Navy until the 1980s. So it was really visionary and really a shame that this character did not get to remain in Star Trek for the rest of its run. We talk about Nichelle Nichols and Martin Luther King and her inspiring women and Black women in particular. And that's amazing and important. But imagine if we'd had a woman as first officer taking control of a Navy ship in the mid-60s. Talk about how inspirational that would have been. There was a bra manufacturer that made the moon spacesuits. Paula Lieberman says the first women were not allowed into military flight training until 1976 or 1977, something like a dozen in the Navy and some months later a dozen in the Air Force. That's right. And we end up having women astronauts in the 80s. it would have been interesting had NASA retained a robust program of manned space exploration, or we should say crewed space exploration in the 70s. Such a thing was unlikely to happen once Nixon took office. And the budget of NASA was being slashed even by 1966. People were tired and bored with space. But if the Soviets had managed to get to the moon, it's possible we could have adapted the Apollo and Saturn infrastructure. Or hey, you know, it'd be better, Gemini. But the reason, of course, we had Apollo was because Werner von Braun wanted the most gold-plated and expensive program possible. He essentially dead-ended our space program. Imagine if we'd had a cheap modular space program based on Gemini that had gone through the 70s because we were competing with the Soviets. Who knows? We might have had women astronauts in space by the late 70s. There's an interesting what if I've never seen. Go ahead and you can take that from me. It's fine. It's free.
Are you talking to me about that they hope that they fit better than most bras do?
The moon suits?
Yes. Oh.
I should probably watch For All Mankind. There are lots of things I should watch. Part of my problem is because I live in 1966, I also have to watch I Spy and Mission Impossible and That Girl and Burt Reynolds in Hawk and other like classics. So unfortunately, my dance card is somewhat full with the past. Yes, Time Tunnel is coming out this week as well. I'll probably watch it. It's an Irwin Allen show, and Irwin Allen shows are not good. You may like Voyage to the Bottom of the Sea. You may like Lost in Space, and more power to you. Paula Lieberman notes that women were restricted from active duty flying, like bomber and fighter pilot. They did cargo plane and training plane. And what's interesting is they were doing that during the war too. Part of the reason women were so discriminated against was backlash, right? Women in the 20s had a lot more empowerment in some ways, and certainly were written better in, say, science fiction. In the 30s, there was a backlash. In the 40s, women got to do men's work because men were all out fighting the war, and women were flying airplanes and working in the factories and Rosie the Riveter and all that. And then men came back and said no. And for the next 15 years, we had an oppression of women like we hadn't seen in a long time. And that's what led to Betty Friedan and the feminine mystique in 63 and so forth. And God, I hate being up here. I hate my gender at times like this because I feel like I'm mansplaining talking about all this stuff to people who probably know it. So I hope you're enjoying it, and I hope you're not offended tonight. I apologize for my entire gender. Hashtag not all men, but most.
Is this what we're saying? On behalf of all women, we forgive you.
Oh, thank you. Thank you. All right. It is 7:50, and I think we're good. Did everyone enjoy themselves? Did everyone have fun? Was this worth doing?
Yes, thank you. You sparked a lot of thoughts for future panels too.
Oh, great. Well, thank you so much. I really enjoyed it. I in some ways probably know more about women science fiction authors, but science fiction and space science are so intricately connected that it was really impossible to learn about one without learning about the other. And I promise that sometime in the next 2 years, I will have an updated list of very interesting women scientists.
Well, we will look forward to hearing that or reading about it on Galactic Journey.
Yes, galacticjourney.org. Please check it out. You will enjoy it. We cover, our space race cover. So I do some of the articles, but our main person is KD, who secretly is Carrie Doherty, who has received the Order of Australia for her space history work. So if you want a perspective from someone who knows what she is talking about, you've got to read the space articles by KD. In fact, I will show you how to read them. I mean, all of the journey is worth reading, and there's lots of super cool stuff. But since we're talking about space, I strongly recommend you read anything by her and hopefully by me about the space program. We cover basically anything of significance that happens in the space race, including a lot of things I'm sure you have never heard of.
Anybody have any last parting questions? Going once, going twice. I think they're going to let you off the hook, Gideon.
Oh, thank goodness. All right. Thanks everybody for coming.
Thank you. Thank you for being with us this year at CoKoCon. It's been wonderful.
Well, I hope to come back in person.
Well, I think, we'll maybe talk about that for future, for sure.
Fantastic. Thanks so much.
Bye, guys.